let's talk about what is energy is. So in universe, everything is made up of two things: matter and energy. We already talk about matter. What is matter is? Matter is any substance that has a mass and occupied some volume. So all those things that has mass and volume comes into matter, right? But they have other thing too that doesn't have mass and volume, right? And those all those component comes under energy, right? So what is energy is? So energy is the ability to do work, right? So you might have already heard this thing: I have a lot of energy, I can do a lot of work, right? So it's just the ability to do work. And there are two different kind of energy that you need to know. One is kinetic energy, second is potential energy. So what is kinetic energy? Kinetic energy is the energy associated with motion. Means how fast you are going, or how fast, let's say how fast the car is going, right? So the car is in kinetic energy. Second one is your potential energy. So potential energy is determined by the position of any substance with respect to the ground, right? Or its chemical composition too. So let's take an example of potential energy. Let's take you hold a pen and then bring the pen like, and then you just take out the pen from the bench and hold it in the air, right? A little bit above on the bench. And then because of the position of this pen compared to the bench, this pen has some potential energy associated with it, right? So what's going to happen if you just drop that pen? It's going to come again to the bench, right? And by and it's converting from potential energy into kinetic energy by movement of the pen, right? So that means energy can be converted from one form of energy to the another form of energy. Means you can convert kinetic energy into a potential energy, or potential energy into a kinetic energy, right? Let's take one more example on this so that you can better understand. So I hope everyone know what is dam is, right? So if you know the dam, you have the water behind the dam. You normally collect the water, right? And because of the position of this water compared to the ground, this water behind the dam has some potential energy, right? That is holding because of the dam. The time you open the door of the dam, what's going to happen? All the water just go, right, just fall from the dam to the ground, right? And what's going to happen? The potential energy is converting into kinetic energy, right? By So this is how you normally convert one form of energy to other form of energy. So like we have conservation of mass, we also have conservation of energy law too. So according to this law, energy cannot be created nor destroyed, but it can be transferable from one form into another form, like we just saw over there, right? From kinetic to potential, potential to kinetic energy, right? But we cannot create any new energy source of energy, right? Okay. So now we talk about what is energy is, what are the different form of energy. Now we're going to talk about the unit of energy, because whenever we calculate energy, we have to assign that number with some unit. So there are two different kind of unit associated with the energy. One is called calorie, second one is called joules, right? Joule. So we have to define what is calorie is. Calorie is defined as the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Means how much energy you required to increase the temperature of 1 gram of water or any substance by 1 degree Celsius, right? And then there's a relationship between the two unit of the energy. Like I said, calorie and joules. You have 1 calorie is equal to 4.184 joules, right? And if you remember from the first chapter, like I said over there, in dimension analysis, whenever you have an equality, you can always make two conversion factor, means two divisible forms. So we can write 1 calorie equal to 4.184 like these two ways, right? I can say 4.184 joules over 1 calorie, or I can flip it. I can say 1 calorie is always equal to 4.184 joules, right? So we call these two divisible form as conversion factor, if you remember from the first chapter, right? And if you know this conversion factor, if you know the equivalency between the two units, we can solve, or we can convert one unit into another unit. We'll do some problem on this, but this is just an overview how you normally use this relation. Similarly, we have 1 kilocalorie is equal to 1,000 calorie, right? So if you remember from the first chapter, again from the prefix multiplier, what is kilocalorie? What is calorie? Is the base unit of energy. What is K? K is your prefix. What is K? K is your kilo, and kilo is 1,000 times. So 1 kilocalorie is 1,000 calorie. So make sure you know this thing, because we're going to use this term and this information to solve a couple of problems, right? Okay. Now let's try to solve some problem over here. So let's try to solve this one. How many calories are obtained from a pat of butter if it's provide 150 joules of energy when it's metabolized? So that means you have to convert 150 joules into calorie, right? So how are we going to solve this problem? So we know how. So first you have to make a solution map, right? Like we already discussed in chapter 1. So you have to go from joules, and your ending should be calorie, CAL, calorie. And we know this joules and calorie are interrelated, right? If you remember, we know 1 calorie is 4.184 joules, right? Now we have to figure it out which conversion factor we have to use, because we can make two. So our final unit that we required is calories. So that means we need 1 calorie on the top over 4.184 joules on the bottom. So this is your conversion factor. Once you made this conversion factor, you have to just multiply the given number with your conversion factor, which is 150 joules, right? And then what's going to happen? Joules will cancel it out, and then you're left with just single unit which we required, which is calorie, right? And if you divide these two numbers, you're going to get in your calculator 35.85086 calorie, right? But how many significant number you need, right? Let's assume if we have a decimal over here, right? 150 decimal. How many significant number you have in this? You have 3 significant number. And we cannot use determine or use these exact number to determine how many significant number we need, right? From the conversion factor. So basically we need 3 significant number, right? So this is 1, this is 2, this is 3, and then the fourth one is 5. So it will increase by 1. So you're gonna get 35.9 calorie, right? And which is and which is almost equal to 36 calorie, which is one of the option, right? If you have the given this option 36, you have to click this option, or else this is the right answer, 35.9, right? So this is the way you normally convert joules to calorie, and similarly you can convert calorie to joules, right? You have to just change this conversion factor, right? Okay, and then let's try to do one more problem on this for conversion of different unit of energy. So here we have to convert 225 kilocalorie to joules, right? So the first question you need to ask, is there any relation between kilocalorie and joules? No, there is no relationship between kilocalorie to joules, but there is a relationship between calorie. 1 calorie is equal to 4.184 joules. right? But there is no kilocalorie. So, but we know 1 kilocalorie is how much, right? This is the base unit, K is 1000. So I can say 1 kilocalorie is 1000 calorie because K is a kilo, right? It's 1000. So we can say that we can go from kilocalorie to joules, but you have to go through a calorie, right? You have to pass through this calorie unit. So you have to have 3 boxes or 3 solution boxes in the solution map. So you have start with kilocalorie. There is no direct relationship. So you have to go through a middle point, right? Which is calorie or middle path. And then this calorie can be converted into joules. Right? And then you have 2 equivalency over here. Then you have to use the first 2 boxes and write the conversion factor between those two, kilocalorie and calorie. So this is the thing that we need to use. So we have to write 1000 calorie on the top and 1 kilocalorie at the bottom, because our desired unit is calorie between the 2 boxes. Right? Now let's take that last 2 boxes, calorie to joules, and then you have to use this equivalency on the top. So we need joules, so joules has to be on the top, which is 4.184 joules over 1 calorie, right? And once you made the conversion factor between the required boxes, you have to just multiply them and multiply with your given number, which is 225 kilocalorie. And then what's going to happen? Kilocalorie will get cancelled, calorie get cancelled, and the ultimate unit that left is joules that you require. So when you solve everything, you're going to get around 941.4 times 10 is power 3 joules, right? And how many significant number you need in your answer? You need 3, because 225 has 3 significant number and you cannot use the significant number from the conversion factor. So you have just one option, 3. So you have 1, 2, 3, you don't need the fourth one. This fourth one is less than 5. So your answer will be 941 times 10 is power 3 joules, right? So this will be your answer for this problem, right? So make sure you practice this kind of problem, right? When you have a multiple boxes, more than 2 boxes, right? In the solution box. Okay, so yeah, this is the way you normally do this kind of problem. So make sure you practice this kind of problem. This is very important for your quiz and exam. Now let's talk about the energy associated with the physical and chemical change, right? We just discussed what is physical and chemical changes, right? And now we're gonna see how these changes affect the energy associated with that matter, right? So that means whenever you have any physical change, you release or absorb some energy, there's a change in energy, right? So whenever you do, let's talk about the chemical change. Whenever you have the reaction, chemical reaction going on, means A reacting with B. Let's take this example over here so you better understand. Let's say you have two reactant A plus B react and provide you a product. Let's say any random C plus D. Right? So it's a chemical reaction. You mix A and B and you're getting a different product, C and D, right? Its own chemical property and physical property, right? So what's going to happen? Sometime whenever the reaction happen, it always accompanied by the release of energy, means some energy is getting released into the environment, right? So you have to just remember this thing. Whenever that reaction happen, it can release energy, or sometimes the reaction required energy before it can convert into a product, right? So we'll talk about both type of reaction, right? Where in that reaction in which the energy is getting released, and the second type of reaction where the energy is getting required by the reactant to convert into products, right? So now let's talk about the first type of reaction, which is called exothermic process, right? What is exo? Exo means outside or outward. Thermic means energy, means all those reaction that are giving out or dissipate energy into the environment. They are expelling the energy, right? We call all those kind of reaction as exothermic process or exothermic reaction, right? So let's take an example over here. What is exothermic reaction is? Let's say you have A plus B, any two reactant reacting together, giving you C plus D, right? Let's imagine the energy of A is 3 joules. The energy associated to B is 5 joules, right? So according to the conservation of energy, when the reactant react, the total amount of energy in the product side has to be 8 joules, again because the combination is 8 joules, right? And every reaction follow conservation of energy rule. So when you have C plus D, let's say you get 4 joules over here and 2 joules in product D. So and then what's going to happen over here, and what happened? The combination of these two energy of these two product is 6 joules. So what happened to the rest of the 2 joules, right? So rest of the 2 joules has to be in the form of energy, right? And this energy is dissipated in the form of heat from the reaction, right? So, and then this energy contain the remaining 2 joules, right? So this is an example of exothermic reaction, right? So remember, in exothermic reaction, the energy of the reactant, this is your reactant side, right? We just discussed, and C plus D is your product that you got after mixing A and B, right? So, so we are talking about for exothermic reaction, just to make sure, exothermic reaction, right? So what we see from the reaction for exothermic reaction, we saw the energy of the reactant is always at the highest side compared to the product side, because some of the energy is dissipated in the form of energy, right? So we can say, we can make one graph over here, and if this y-axis tells you energy, this is your energy E, right? Increasing upward, right? And this is your, let's say, reaction time or reaction rate, right? So can we make this kind of graph? Right? So this is your reactant, this is your product. And if you can see the the amount of energy in the reactant is higher compared to the product, right? Why? Because some of the energy is released in the form of energy from the product, right? Now it doesn't have the same amount of energy that is there started with, right? So if I give you this kind of graph, so you should know this is an exothermic reaction, right? Okay, so yeah, so that will be it for your exothermic reaction. Okay, one more thing you need to remember for this exothermic reaction is, whenever the exothermic reaction is going on, the atmosphere surrounding that reaction will become hotter or warmer. Why? Because the extra energy that is dissipated in the form of heat is going into the environment or the surrounding, and because of this, the temperature of the surrounding will getting increased, right? So remember, for exothermic reaction, the surrounding area of the reaction is always getting warmer or get hot, right? Now let's go to your slide again here. Right, so we just discussed everything over here. The energy is released into the surrounding, and then this is an example, right? Burning of a gas. So this is type of exothermic reaction. Right? Energy is released in this kind of reaction. That's why the surrounding always getting hotter. The second one is endothermic reaction. So what is endothermic reaction? Let me explain on this. So endothermic reaction, endothermic. So the name is already saying endo means inside, you're providing something. Thermic means energy, right? So you're providing energy. So there's some reaction. Again, let's say A plus B react to give C plus D. But whenever you react A plus B together, it doesn't react, right? It needs some kind of energy to initiate. The time you provide some energy, let's say you provide some energy to the reactant A and B, it convert into C plus D. But if you don't provide energy, the reactant doesn't convert into C plus D. So that means energy is required for this reaction before it convert into a product. So this is a type of endothermic reaction. So let's take one example over here. Let's say that the energy associated with A, let's say is 5 joules, B is 3 joules, right? But to initiate the reaction, you need some, so what's the total amount of energy that you have in here? 8 joules altogether, right? But the reaction need a little bit more amount of energy, right? That need to be compensated, right? Before the reactant can go and convert into a product C plus D. So if you provide, let's say 4 joules of energy in the form of heat, so altogether, how much energy you have? So let me remove this one and then we'll do this. Okay, so it's here. Okay, so the time you provide the energy to the A plus B to convert into C plus D. And now let's say C product has 8 joules of energy when it formed, and D has 4 joules of energy, right? So what's happening over here? If you can see in endothermic reaction, the energy of the product side, which is 12 joules, energy of the products are always higher compared to the energy of the reactant, right? Why? Because this extra amount of energy that is provided to the reactant is also converted inside in the product, right? So remember, for endothermic reaction, energy of the product is always higher compared to the energy of the reactant. So if you make the same graph again that we made for exothermic reaction, so this is your energy, right? Energy increasing upward, and this is your reaction. So how does the graph look like? So it should look like something like this. Right? We can say this is your reactant R, this is your product. And if you can see you will have higher energy in product compared to the reactant, right? This high energy, right? Because you are providing extra energy that is converted into a product too, along with the reactant energy, right? So this is a graph for endothermic reaction, right? And the last thing that you need to remember for endothermic reaction is whenever there is an endothermic reaction going on, it makes the surrounding a little bit cooler because endothermic reaction take up the heat from the surrounding and make the surrounding a little bit cooler compared to the compared to the exothermic reaction, right, where the energy is being released outside. So make sure you know all these small term and all small thing for endothermic and exothermic reaction. And yeah, that will be it for these two reactions. Okay, so let's go again over here. Let's go again. So this is an example for endothermic. I think most of you already use that ice pack whenever you get some burn, right? So why this is an example for an endothermic reaction? Because whenever you have a burn on your skin, it releases some energy because of the reaction of the body, right? And then and that extra heat is getting, and the ice cold has the ice in it, right? And then when the energy or the heat released from the skin, it getting used by this ice pack. So for ice pack is a kind of endothermic reaction because it's absorbing the extra energy that is coming out from the burn from the skin, right? So this is an endothermic and making the skin a little bit cooler, right? The surrounding for ice pack skin is like a surrounding, right? So this is a difference for endothermic and exothermic reaction.